Let's look at some alternative indicators that are popular but not particularly well rooted in economic theory. The Human Development Index is often used to compare countries and to track the development of countries over time. It consists of three indicators: GDP per capita, life expectancy at birth as an indicator of health, and then an indicator for education, which is a weighted average of the adult literacy rate, what fraction of adults can read and write, and the enrollment rate, what fraction of kids who are supposed to be in school are in school. You can't add up these things because they're measured in different units. So what they did is they scaled them from 0 to 1. So the richest country with the highest per capita income scored 1. The country with the lowest per capita income scored 0, and everybody else was rescaled to fit somewhere in between. The same for the other two indicators. And then the average of the three is taken. The selection of indicators is fairly arbitrary. Of course, taking the average, giving them equal weight, is fairly arbitrary too. Most important from our perspective, there's no environment in there whatsoever. The next two indicators do have environment in. I'm going to talk longer about the ecological footprint, but there's another one that is often used, but bizarre. And that is the Happy Planet Index. The Happy Planet Index is defined as life satisfaction times life expectancy divided by the ecological footprint. Why this particular functional form is unclear. Life satisfaction is increasingly measured in all sorts of surveys where essentially the question is, how happy are you with your life in general on a scale of 0 to 10? People answer these questions. And what you find is that people from particular countries answer in a particular way. Numerically, or the min and the max are 0 and 10, but if you look at the data, then the lowest score in the data is 2.7, the most miserable country scores 2.7, and the happiest country scores 8.0. That is then multiplied by life expectancy. Don't know the theoretical range of that. Starts at 0, but we don't know when it will end. But the data say it falls between 44 and 75. So numerically, this means that here you have a factor of more than 2, almost 3, and this varies only by a factor of less than 2. So numerically, life satisfaction will dominate life. Variations in life satisfaction will dominate variations in life expectancy. Life expectancy is sort of a harder measure. It's much more objectively measured with much larger data sets, but in this particular index, life satisfaction dominates. But then they divide it by the ecological footprint, and the ecological footprint does have a theoretical scale between 0 and 100. And some countries score very low on the ecological footprint, 0.02. And if you divide by a small number, you get a large number. And that means that this particular Happy Planet Index put a whole lot of emphasis on countries with a very small ecological footprint. And that explains some of the strange results that you get. So the Happy Planet Index is measured for basically every country. And here are the top 10 countries and also the bottom 10 countries. And some of the bottom 10 are indeed fairly miserable places. Congo, Burundi, those are perhaps not places where you would like to live. But also it has Estonia, almost near the bottom. Estonia is a fairly decent place to live. And then if you look at the countries at the top, Honduras, Guatemala, El Salvador, you follow international politics, then you know that people are running away from these countries as fast as they can. And this is one of the reasons that Trump is so upset about it. People are fleeing these countries, yet they are deemed to be some of the best places on Earth to live according to this particular Happy Planet Index. Let's focus in on some countries that we know. United Kingdom scores 108 out of 178, and apparently it lies somewhere in between Libya and Laos. The idea that you're better off in Libya than you are in the United Kingdom is somewhat peculiar. Ditto for the United States, scores lower than Burkina Faso, which explains why everybody in the United States is trying to migrate to Burkina Faso at the moment. So this is a peculiar index, but it sort of illustrates the dangers of trying to put together an index that makes sense. The defining feature in the Happy Planet Index is the ecological footprint. So what is that? Essentially, the ecological footprint tries to come up with an idea of, it tries to be a measure of strong sustainability. Their claim is that there are ecological limits to what we as humans can do, and those ecological limits can all be expressed in terms of land. And the idea here is that there's a carrying capacity. So many people that can live on the planet. This is a very classical economic thought, right? That somehow we're going to go to a stationary state. Somehow human expansion will stop at some point, because simply there won't be it's not possible to fit more people on the planet. And not only is there this carrying capacity, but also what they then try to measure is how much of that carrying capacity has been appropriated, how much of that carrying capacity is used. And this is partly the classical thought, the classical economic thought of going to a steady state that is associated with Malthus, but the idea that everything can then be expressed in terms of land is, of course, the idea of the physiocrats, right? So, in terms of economic history, the ecological footprint sort of mixes up ideas that classical economists had and have been thoroughly refuted by the neoclassicists, but also ideas that the physiocrats had that has been thoroughly refuted by the classical economists. So it's historically an intriguing concept. The two gentlemen that developed this are shown here, Wakanago and Rees. Rees had the idea, and Wakanago puts the data to it. So, what is the ecological footprint? How do you calculate it? Some of the things that in there are entirely sensible. So, the ecological footprint of grazing land is how much land is being grazed by animals that are directly used by humans. The forest footprint is how much land is used for timber and pulp and all those sort of things. That makes perfect sense. I'll get back to the fossil fuels. For fishing, essentially what they do is they say how much fish do we take out, and if we out of the sea, and if we can't do that anymore, how much land would we need to offer the same amount of calories to people, which is peculiar, because essentially this says the oceans are off limits and we are restricting ourselves to the land area, and oceans don't matter. It is somewhat bizarre idea. Um, Results are like this. This is the global footprint over time. And essentially this tells you what share of the Earth, or rather, yeah, it's Earth, it's the solid ground, it's not the water part of our planet. What share of the land do we as humans in total use? And that's broken down by category. Build-up land is actually a fairly small fraction. Cropland is much larger. Grazing is smaller than that. Somehow they moved all the fish onto land. There's forest there, and then there is the CO2 emissions as well. And this picture suggests that somewhere in the 1970s, I think it's 1976, we as humans used up the entire world, and ever since we have been using more than the actual carrying capacity. That is, we're running down the planet, and that of course will eventually lead to trouble. So this is classic Malthusian overshoot. You can do that for the world as a whole. You can also do it for individual countries, and that has suggested the overshoot days. Essentially what this says that on February 11 of this year, Qatar had used all of the land that is available to it. And on March 14, the United States had used all of the land that is available to it. And the implication, of course, then is, because then you're only 1/5 of the year in, that if everybody were to live like the United States and everybody had the same amount of land like the United States, then we would need 5 times the land that we have available to us. We would need 5 planets to support this. And you can look up for every country, United Kingdom was May 16. So the UK uses more than twice as much as it has at its disposal. So that is what this data is used for, and the question is, what? And more than half of the global footprint is due to CO2. And that comes from fossil fuel combustion, which is pretty awkward because fossil fuel combustion is not about land, it's energy. It's important, and it sits awkwardly in this framework. And the way they count CO2 emissions is not by the inputs, but rather by the outputs, by the waste product. So fossil fuel combustion is measured by its carbon dioxide output, not by the heat that it generates, that keeps people warm, that propels your car, or that cooks your food. No, it is accounted for only by its waste products. So fossil fuel combustion is assumed to have no intrinsic value. It is just there for, it's just counted for by its waste. And then the way it is accounted for by its waste is arbitrary, essentially, because what they say is, well, CO2, we don't want that, we want to keep that constant. So we're going to account for CO2 by what land would be needed to suck that CO2 out of the air again. And one way to get CO2 down is to plant more trees because they suck up CO2. And if we emit 100 million tons, then we would need to plant so and so many trees to take up 100 million tons, and that would take so and so much land. That is how they account for CO2 emitted. As I said, that is fairly arbitrary. You can indeed suck CO2 out of the air by planting forests, but you can also replace fossil fuels by biofuels that are grown on land. That is another way of transforming CO2 emissions into land required, but you can also avoid CO2 emissions altogether by using wind power, and then you can calculate the area needed for wind turbines or for solar cells. That would be just as valid, or just as invalid, I should say, but it would be an alternative assumption. And they completely ignore other options to cut CO2 emissions, such as home insulation, energy efficiency, and what have you. So this is fairly arbitrary, but it's also incredibly important in the calculation. Other things they just don't do. Other waste besides CO2 is simply not there. Nuclear waste not accounted for. Toxins not accounted for. Water is just not there. And if you look at the results by country, then Qatar fares so badly, or Luxembourg fares so badly because it's densely populated, fairly small places. And the implied assumption here is that a country like Luxembourg is supposed to live within the boundaries of Luxembourg. That is, international trade is bad. And Luxembourg, of course, exports lots of services and imports basically everything else because it's small, it's densely populated, there is just not a lot you can do, and it's also in a particular geographic location that even if you had the space, then you simply could not grow a lot of things in this country. So if you're a small country, almost a city-state, then yeah, obviously you're gonna import a whole lot of the things that you need, and the idea that you should be confined within your country is very much an anti-trade agenda. The assumption here is that countries should not trade, that they should be autarkic. So that is a particular assumption that they make. It is an indicator of some sustainability in a way, because you're focusing on how much land are humans using and what is the amount of land that they could use, so that there is sort of the idea that humans cannot encroach on the space of other species. But at the same time, it is assumed that in natural space there is full substitutability between those things. That essentially everything can be added up to one particular indicator, one particular capital stock, and the different variations are different kinds of natural capital can all be added up and expressed into one. So there's full substitutability between the different types of natural capital, but no substitutability between human capital and natural capital. So it is a fairly peculiar way of looking at the world. Even if you accept the needs of strong sustainability, then it's still a fairly peculiar way of doing things, but it is also very influential.